on page 117. This is question 2. Now what I've done is prepared a graph on the right hand side. I've not done any more other than prepare the graph. I don't know if I need greater distances. I don't know if I need more time in the day to get all the information on the graph. What I've also done is shown you the scale I've been using. I've actually calculated that if I've got 10 squares from 9 AM to 10 AM, every square must be worth 6 minutes. And similarly, from 0 to 5 kilometers, a certain distance from P, and I've got 10 little squares, then 2 squares make a kilometer. And that could be useful once I start plotting. Now I'm going to take this as it comes, and if I crash, what I'll do is pause and then think and get back to you. It can happen. Now, hint, you may use, this is question 2, you may use graph paper to help you solve this question. I see no other easy way of doing it. So, hence the graph. At 9 AM, a man leaves point P and walks along a road at a steady speed of 6 kilometers per hour. I'm going to plot that straight away. I don't think this man's doing anything else other than walking. I've got a man walking, I've got a cyclist, and I've got, what's happening? That's what I'm going to do. Right, and part B, I've got a motorist. Anyway, so let's see if I can just do it bit by bit. And if I need to extend the graph, I'll do that. At 9 o'clock, a man leaves point P and walks along a road at a steady speed of 6 kilometers per hour. He's not doing anything else. Yeah, that's it. So if I can do that, that should be helpful. Right, I'm starting at 9 and I'm going to walk up the road from this point P. So obviously the point 0, 0 is where it all starts at. So if I'm doing 6 kilometers per hour, then 30 kilometers should be done in half an hour. So half an hour will be just about there, I think. Let's check carefully. Leaves at 9, does 6 kilometers per hour. Therefore 1 hour is 6, 2 hours is 12. So 5 hours should be 30. 1, 2, 3, 4, 5. So he may not be walking until 2 o'clock, but I'm going to use that point because at this point he will have walked for 5 hours at constant speed, 1, 2, 3, 4, 5, and he would have done 30 kilometers. Well, that's 30 kilometers in 5 hours. Well, if you do the sum, 30 divided by 5, you have 6 kilometers per hour. Therefore, this will be the graph for the walker. Go to black, start at 0, 0. Now, I may not need all this information, but that's what I'm going to do. This is the person who's walking. And hopefully that should be fine. Next part. At noon, that's 12 o'clock, a cyclist leaves P on the same road in the same direction at a steady speed of 20 kilometers per hour. It's a cyclist. So I'm going at 20 kilometers per hour, and I'm leaving at 12 o'clock noon, and I'm also leaving from the same point P. Then it says after travelling for an hour, the cyclist gets a puncture. Right, so I'm going to travel for an hour at 20 kilometers per hour. So guess what? I'm going to cover 20 kilometers, and I'm leaving P at noon. In other words, I'm coming from this 0 point here, distance from P. I'm not starting up here somewhere 15 kilometers from P. I'm starting at P. So I'm going to start right there at 12 o'clock, and in 1 hour I'm going to do 20 kilometers. So here I go, 20 kilometers per hour for 1 hour. Let's see if I can show that bit. Do some reading just to check out. After travelling for 1 hour, the cyclist gets a puncture. Okay, so 20 kilometers per hour, wrong way, sorry, 20 kilometers per hour for 1 hour. Well, that's 1 hour, and 20 kilometers per hour will put her right there. So I'm now going to draw that person's graph. I'm going to do it in blue. So from here to here, our cyclist did 20 kilometers per hour, and that's the hour in which he or she did the cycling. Let's just check the time. Yeah. After travelling for an hour, the cyclist gets a puncture, which delays her for half an hour. So she can stay where she is for half an hour. So let's do half an hour. Half an hour is from 1 to 1:30, isn't it? So if I do a little join like that, that's what she's now doing. Alright? So she's done 20 kilometers per hour for just the first hour, and then stops for half an hour. Alright, let's go back and see what we get. She then continues at 20 kilometers per hour until she overtakes the walker. Alright then. So it doesn't mean to say that she's going to do an extra whole hour, but I'm going to pretend she's going to do an extra hour from there to there, and let's add 20 kilometers on. So from 20 kilometers up to 40 kilometers, let's just plot the points, it would be easier, wouldn't it? So let's say she's taking off at 1:30. At 2:30 she's been travelling for an hour, so in order to go at 20 kilometers per hour, she would have gone 20 kilometers in that hour. So from 20 kilometers up to 40 kilometers, that will represent the second leg in the cyclist journey. And I think her coding is blue. Yes, so she stopped for half an hour, then carried on cycling up there, and there it is. Alright, so I think that's the end of her story, and this is the cyclist, and I'll do that in blue. Alright, starts at midday, goes 20 kilometers for the hour, stops for half an hour, then carries on going at 20 kilometers per hour. Again, it doesn't matter when she ends, we're just going a certain distance from P, it doesn't matter, but clearly she has overtaken the cyclist. Sorry, the cyclist has overtaken the walker. Let's see what the motorist is doing. So that's done. At what time did the cyclist overtake the walker? Oh, well, let's have a look. Well, there's our walker, and there's our cyclist. And we have her overtaken at exactly 2 p.m. Alright, just read down point of intersection, 2 p.m. and that's at a distance of 30 kilometers away from P. Doesn't ask us about the distance, it asks us about the time. So let's just do it then. At what time did the cyclist overtake the walker? Answer 2 p.m. Alright? Now, complicated. A motorist leaves P travelling at a steady speed of 50 kilometers per hour. The motorist overtakes the walker at the same time as the cyclist. This is complicated. At what time did the motorist leave P? Well, 50 kilometers per hour. This is really complicated. Let's just have a look at that one. So the time must be there at 2 o'clock. So I need to work out backwards if I know the speed, then I know the gradient of the graph. So let's just take a look. So let's just do a little calculation here because I've got space for it. So I know speed equals distance divided by time, and my speed is 50 kilometers per hour and 30 kilometers. So let's just substitute into this formula here. We'll work in red. So I've got 50 kilometers per hour equals a distance which is 30 kilometers divided by time in hours. So rearranging, I've got time equals 30 divided by 50, which equals 0.6 of an hour. Now, not very helpful, but it's a step. Now, 0.6 of an hour. Now, there's 60 minutes an hour, obviously, so if I take my 0.6 hours and multiply by 60, I'll get exactly 36 minutes. Therefore, if the motorist overtook both the cyclist and the walker at exactly 2 o'clock, then she must have started her journey 36 minutes before 2 o'clock arrived. Therefore, it must be, so the time motorist started the journey is 36 minutes before 2 p.m. and therefore you're looking at 1:24 p.m. Alright, that's really sort of tricky, isn't it? Let's just review that last little bit. We're going at 50 kilometers per hour, but I don't know what time I'm starting. I'm starting from P, so I'm definitely along the bottom axis here somewhere. At 30 kilometers, I overtake both the cyclist and the walker at exactly the same time, and that time is 2 o'clock. So 50 kilometers per hour, having travelled 30 kilometers, how long did it take us to do that? Working backwards, that took us 36 minutes to do that, and if we overtook at 2 p.m, then the motorist must have started 36 minutes before 2 p.m, and therefore we're looking at 1:24 p.m. and that is it. And these are quite hard, I thought, and I'll stop there and look at the next chapter.